Good day, everybody, and we meet yet again. And today, I just wanted to do this past exam question. This is from the IEB. I just want to let my IEB people that I'm still your plug as well, and I've got your back as you prepare towards your exams. I'm going to be doing quite a number of IEB past questions. And by the way, ladies and gents, I just want you to know that. IB and the NSC, that's for you in South Africa, there's really not much of a difference. There's just a few differences here and there. Well, I've been privileged enough to actually write both exams, to sit under both exams. When I did Matric the first time, I wrote the SCE, Senior Certificate exam, but then I repeated Matric and I did the IEB exam. So yeah, so just stay with me as I answer this question, and our approach is simply going to be the same. Remember, physics is physics, okay? So let's do this question on circuits. Let's look at it together. So if you haven't subscribed, please make sure that you subscribe, and yeah, tell others about our channel, that you're learning quite a lot. Okay, right, let's go. So I've got a question here. This is from 2019 IEB. Okay, it says in the circuit represented below, the battery has an EMF of 15 volts and an unknown internal resistance. So voltmeter V1 is connected across the battery, and voltmeter V2 is connected across the switch. So there's our V2 there, there's our V1 there. And then they say the resistance of the emitter is negligible. So it means that our emitter has zero resistance. Okay, we can assume that. All right. Now they say to us the switch is open. Now please, I want you to note, ladies and gents, so when that switch is open, remember that there's no current that is that is moving, that's flowing in the external circuit, right? So what that simply means is that if I were to measure the voltage across V1, that voltage would measure 15 volts, the value of the EMF. Why? Because there's no external, there's no internal resistance. It's not effective. Not that there's no internal resistance, rather, but there's no voltage that is lost due to the internal resistance. Remember, we can only lose voltage, okay, or have a voltage drop once there's current that is flowing, okay? So in this case, we know that we will not have that voltage drop. And by the way, just for interest's sake, when you look at V2, resistors can only start resisting, so to speak, once there is current flowing. So if you look at V2, the one leg of it is actually somewhat connected to the negative side of the cell, and the other leg connected to the positive side of the cell. So in a sense, also V2 would actually read the same value of the EMF. Okay, I know some of you might not believe that, but it definitely would. Okay, why is that? Because if you look at that, the one side of V2 is actually connected. Remember, these are only conductors, before current flows. And that's another conductor, and it just connects the battery to V2, the other side of V2. So in this case, they say define potential difference. Okay, so potential difference, remember, we say that it is the energy, okay, per unit charge across a resistor or across a conductor, right? So it's the amount of energy per unit charge, okay, across a conductor, right? So they say determine the reading on V1. Okay, that's what we've just said. V1 would be 15 volts. Okay, and they say determine the reading on V2, and V2 would also be 15 volts, of course, provided that switch S is open, right? Now I'm gonna just move this up a little bit so that we just have the circuit. All right, now they say to us determine. Okay, now they say the switch S is now closed. So when switch S is closed, I want you to note what's going to happen. First of all, is that now it means that we've got current that is moving in the external circuit, okay? And what that means is that the voltage would drop across that resistor there. Did I say resistor? No, I meant across the battery there, right? Why is that? Because all of a sudden, because there's current flowing, right, the internal resistance would now come into effect, and it would actually take away some of the voltage, okay, that is supplied by the battery. So you'd have kind of voltage that is lost due to the internal resistance. So essentially the voltage V1 would be the voltage it would be the EMF minus that in the voltage that is lost there, and that would be the voltage that is actually supplied to the rest of our circuit. Okay, all right, let's not talk a lot, but let's rather tackle the question. So they say to us the reading on voltmeter V1 drops to 10.5. That's exactly what we said. So it means that there's 10.5 volts that is supplied to your external circuit. Okay, so let's keep that in mind. Now they say to you, use a suitable equation to explain why the reading on V1 drops. Okay, right, I'm going to use, okay, the fact that I know that EMF, okay, so I'm going to do this. I'm going to say EMF is equals to V external plus V loss. Okay, now in this case, what happens to V loss? The moment that we have current that is flowing, okay, my value for V loss increases. Okay, so it means, remember it was 0 at the beginning, right? So V loss increases, okay, but remember EMF stays constant. Okay, so I can actually explain that in this case my V loss would increase. Okay, but remember that EMF stays the same, the EMF of the battery, as long as you don't change that battery, okay, or that cell, whatever it is that you're using. Okay, in this case, so the EMF remains constant. Now think about it. If this value remains constant and that one increases, remember this plus that should give us that, right? So what should happen to our V external? Okay, it should definitely decrease. So EMF remains constant. Okay, so in this case it would cause our value for V external to therefore decrease. Okay, I hope that makes sense to you. All right. Okay, so moving swiftly along, so they say to us, okay, now we need to calculate the reading on the emitter. Okay, so we're looking for the total current there. So what's going to happen in our external circuit? Now I'm going to have total current, okay, flowing out there, and it's going to flow through R1 at the 1 ohm resistor. Okay, and what happens? Some of the current would, now of course our current would divide. Some of the current goes through the 6 ohm and some goes through the 12 ohm, and so it means these two are in parallel. But remember, the effective resistance is in parallel. Once I put these two together, they become one resistor, and that resistor now becomes in series, okay, with that 1 ohm resistor. Okay, so we want the total current. Okay, but what do we have? We always start where we've got the most information. So which voltage did they give us? They gave us the external voltage. Remember I said to you corresponding voltage, or rather voltage with its corresponding resistance, right? So what does the battery, which resistor does the battery supply, right? So we said it supplies the entire external circuit. Okay, so as a result, what I will simply do is let's find the external resistance. Okay, so this is now answering 7.1 point oh no, actually I skipped the question, sorry about that. They said calculate the effective resistance of the resistors in parallel. So so that's 7.1.5. okay, yes, so 7.1.5, they wanted the effective resistance of our parallel resistors. So by the way, I've shown you a shortcut, so we can say R parallel, that's product over sum. But remember, ladies and gents, you can only use this when you've got when you've got two resistors, right? When you've got more than two resistors, obviously you need to revert back to that 1 over R parallel is equals to 1 over R1 plus 1 over R2. Okay, and please remember, when you use this equation, okay, once you add, that's going to be 1 over 6, 1 over 12. Okay, you get the sum of that, but remember that you still need to invert it, okay, to get the effective resistance. Okay, now let's calculate that. So I'm going to have 6 multiplied by 12 divided by 6 plus 12, and I get a value of 4 ohms. So my resistance value there for R parallel, so it means those two resistors put together will give us an effective resistance of 4 ohms. Now please remember, once I've actually now put them together, so it means that I've got a circuit that has that 1 ohm resistor there, okay, as well as, okay, so that's 1 ohm there, and it means that now these two have become one resistor, and that resistance is 4 ohms, right? Okay, I know that's an ugly circuit, but nonetheless you get the point, right? Okay, so moving to the next question, they say calculate the reading on the emitter. So now you'll notice the total current, the current that is moving there, would be the voltage, the current that's moving through I1, rather the 1 ohm resistor as well as the 4 ohm resistor. So what does that mean about those two resistors? They must be in series, right? Okay, I'm just going to move this a little bit. Okay, so those resistors must be in series. So in this case, what I can actually do is that I can say, all right, so what's my external resistance? So R external, now I'm answering the one 7.1.6. Okay, so my R external would be R1 plus R2, okay, or R parallel, whatever you want to call it. Okay, so that would be equal to 5 ohms. That's 1 plus 4, right? But we're looking for the total current. Remember, we've got the external voltage that was supplied. So now I can just simply say, okay, but my total current is equals to V external. Remember, we said voltage with its corresponding resistance, right? So it's going to be V external divided by R external. Okay, so what does that give us? That's 10.5 divided by 5, and we get a value of 2.1. Okay, so that's 2.1 amperes. So that's the total current that's flowing in the external circuit. Okay, right, sorry about that. Okay, so that's the total current that's flowing in our external circuit. So now I'm just going to move this over to this side so that okay, just remember that we've got a total current that side. All right, now what we want to find in the next question, okay, now they say to us we need to calculate the internal resistance of the battery, right? So for 7.1.7, we wanted to find the internal resistance. So now I'm going to just use E is equals to I into R plus small r. But remember, so if I look at the the EMF, we were given that EMF value. But remember, when we're using this equation, please keep in mind, we said which current do we use here? It's going to be the total current, okay? And which resistance are we going to use there? It's going to be the effective resistance, right? So let's substitute. We said our total current was 2.1. Our effective resistance, if you remember, we said our effective resistance was the one that we got there, which was 5. Okay, but we don't know what the internal resistance is, right? So we're going to do some mathematical gymnastics there. So we're saying 15 divide by 2.1. So I'm going to divide both sides by 2.1. Okay. And after that, of course, I'm going to subtract that 5. Okay. And we get a value of 2.14. Okay. So it means that my internal resistance would be 2.14 ohms. Please just verify and make sure that that value is correct. Okay. And if it isn't, please just throw it in the comments there. And yeah, well, of course, I know you know what to do. Okay. Right. So that's how the cookie crumbles when it comes to this circuit. Okay. And by the way, I hope that you can see that there's absolutely nothing different. Okay. Just an interesting comment. If they had asked us what would be the value on V2 when the switch is closed, you'll notice that our V2 would now suddenly be 0, right? Why is that? Because we assume that a switch has no resistance, okay? So there's no potential difference. There's nothing in between the two terminals of that voltmeter there. So in that case, it would not measure a difference in potential, okay? There's no difference in potential between those 2 points. So our V2 rather value would actually be 0. Okay, I know we weren't asked that, but just an interesting comment just to throw there. So let's go to the next part. They say an electrician needs to replace a bulb that is a 20-volt supply. Unfortunately, the only working light bulb in stock is rated 50 volts and 100 watts. Okay. All right. Now they say to us calculate the resistance of the 50 volt 100 watt light bulb. So not only do we have the voltage, okay, rating, but we also have the power rating, okay, and we want resistance. Remember, you've got three formulas that we use for power, right? So that's P is equals to V times I, but we also have P is equals to I squared R, but we also have P is V squared over R. So you just need to keep in mind which formula do you choose, or how do you choose a formula for power. So you're going to choose based on, first of all, what you're given. So we've got both power and voltage, okay, and we wanted resistance. So I wouldn't have gone for this one because we don't have current, right? And nor do they want current in that particular question. So I'm going to take the third one. So my power rating there, that's 100 watts, okay, and it's 50 squared, okay, and divided by resistance, okay. And all we do is just a mathematical gymnastics, and what do we get? Okay, so that's going to be 50 squared over 100, or just to show you. So you would have had 100R if we cross multiply there, which is equals to 50 squared. So let's take that. So that's 50 squared, okay, divided by 100, and we get 25. So 50 squared, by the way, was 2,500. Then divide both sides by R, and R would give you 25 ohms. So it means that the resistance of that light bulb would have been 25 ohms. And then finally, okay, well, almost done with the question. They say calculate the current that should flow through the working light bulb, okay. How much current should flow through that light bulb? Okay, so all that we'd simply do, we'd say, okay, but we know the power, we know the voltage. Okay, you can either use V's I over R, in fact, let me use exactly that. I is V over R, okay, or rather, I should have said R is V over I, right? So my current value, all right, is what I want, okay. My voltage, remember they had said that's 50, and my resistance I know now is 25. Okay, and in this case that would simply give me 2 amperes. Okay, right, I'm just going to complete the rest of the questions over this side. Okay, right, so that's my that's the amount of current that should flow there. All right, so they say that the electrician uses 50 volts, the 50 volt 100 watt light bulb, and connects a resistor in series, okay, with the light bulb to ensure that the light bulb operate at its operating rating when connected to a 220 volt supply, right? Okay, I want you to just think about this in simple terms, right? So you want to cause this light bulb, okay, suppose we say, all right, so there's our light bulb. Okay, let me draw the light bulb over there. Okay, and we want to make sure that this light bulb operates at the correct rating. Okay, so what should we do? We're going to now connect a resistor in series. So what I'm going to do is I'm going to connect a resistor in series with the light bulb. Now what do we know about resistors? So there's our there's our supply there. Okay, what do we know about connecting resistors in series? So our supply is 220 volts. Okay, but I want this guy to operate at 50 volts. Okay, all right, so I need to make sure that I connect this this light bulb, by the way, at the correct in series, so that that voltage drops there. Remember that when you connect a resistor in series, okay, what it does is that you divide the voltage, okay, but what you also do is that the current remains the same across your resistors, but it will increase the resistance, the effective resistance of your circuit, and it would actually decrease the current. Okay, right, so we want to know what should be the value of this resistor over here. Okay, so now, right, remember we know the resistance of the light bulb. Okay, so what I'm simply going to do is I want the current operating, or rather I want the current on that light bulb to be 2 amperes. So what I'm going to say is, okay, I know what my V external is, that's 220. Okay, it should be divided by my R external, but what is my R external? It's going to be R plus 25. So I'm simply going to say, okay, in order for us to get our R external, now please, I want you to follow me in this. It's going to be our V external divided by our total current. And what did you want our total current to be? We wanted it to be 2 amperes, right? So I'm going to say, well, my V external is 220. Okay, my I total, I wanted it to be 2 amperes. Okay, so that would give me 110, sorry, that's 110, okay, amperes, 110 ohms. Okay, so that's 110 ohms. But what is our R external? We said that's R plus 25, right? So in this case, how would we get the value of R? So it means R plus 25 should give us 110. And what should be the value of R? Of course, you got it. It's the difference between the two. So we're going to say minus 25 there. And it means that our value for R is going to be 85 ohms. So it means that you must connect a resistance there of 25 ohms. So I hope that makes sense, ladies and gents. You can go and check out this question. It's from the IEB 2019. Okay, so it was a November paper, and very interesting question. So I hope that you'll stay subscribed, and obviously you'll tell others. I'll be doing some more IEB questions, okay? And remember, for those of you who are doing the NSC exam, it's more or less exactly the same things, okay? So you shouldn't actually worry too much about it, okay? Right, otherwise I'll see you guys next time. Please remember to subscribe for those who haven't, and please tell others, okay? I'll see you next time. Sharp sharp.